Okay, I gave you this question at the end of the last video, and the answer is obviously no. Obviously no. It's really silly to say that the average is $50 because 0 is much more likely than 100. But $50 puts equal weights on both, which is unfair. So you have to put much more weight on 0. So the average will be closer to $0. And it's clear, so the mean is in the previous question, the mean is calculated this way, which is not wrong because the outcomes are not equally likely. If you look at the definition, the mean is the sum of probability weighted outcomes. So in one sentence, this is the mean, this is the average. So mathematical definition of more formal definition of the average. So the point is probability weight. You have to weight probability to the outcome. Otherwise, you get this kind of result, wrong average. So then, as I said, if you weight their probability, 100 will be multiplied by 1%, 1 out of 100, but 0 will be multiplied by 0.99. So the answer will be, the average should be $1. You get $100 in like once out of 10 times, once out of 100 times. So on average, you get $1. Right? So now let's discuss how to calculate the mean. So we learned the mean is the sum of probability weighted outcomes. And then we can just apply that to calculate the mean. But to 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 formulate the way to calculate the mean, we need to consider two different cases. What kind of information do we have? So what kind of data or information from we use to calculate the mean? We have two types. First, raw data. Raw data is just list of outcomes. So repeated experiments and just list the outcomes from each repetition, each experiment. So in our previous example, student 1, the first student, took a random economics course and get a grade. And he or she repeated taking economics courses for 10 times and got these outcomes. So just write down 10 outcomes. This is raw data. So it is unprocessed data. But if you process it to a frequency or probability distribution table, you get something like this. So summarize the data into a table. So how many times the student got A? Once. How many times the student got A minus? 4 times. In that way, the raw data has been summarized into a frequency distribution table. So depending on what you have, your calculation method differs. So you should tell what you have, right? Let me talk about the first case first. So suppose that you have a raw data. So simply you observe n experiments, and you get n number of outcomes from the repetitions. So I will denote those outcomes and outcomes as x1, x2 up to xn. Of course, they are numbers. And remember, the mean is the sum of probability weighted outcomes. However, in this raw data, there is no probability calculated, right? So what we are going to do here is, they are just outcomes with a probability. So what we are going to do here is, we are going to give them the same weight. Because the weight has to sum to 1, I'm going to put the equal weight of 1 over n for each outcome. So x1 will be multiplied by its weight 1 over n. x2 multiplied by another the same weight, and n different outcomes get the same weight. So in the end, they can be written as sum of all outcomes divided by n. So you can factor out 1 over n and just put it in the denominator, common denominator, right? So this is the formula you usually see from the textbook or what you learned like in the elementary school or when you are younger. So a simple way to calculate the average. And right, so the point here is, remember, the mean is the sum of probability weighted outcomes, and probability weighted, here we are using the same probability, equal probability on all the outcomes, because there is no other probability given, right? Intuitive. In this case, let's think about this example. Just simply sum all the outcomes, sum the 10 numbers, and if you sum them, 34 plus 7, and divide them, divide it by the number of observations, the sample size. There are 10 numbers, so divide. So numerator has the sum of 10 numbers, and denominator has 10. So the average is 3.47, right? I believe it's so easy. This is what you know, and I'm not going to do any more than this, right? And now we are turning to the second case. The second case is when you have, when you have probability distribution table. So if you have frequency distribution table, what you need to do first is to convert the frequency into probability. We learned how to do that in chapter 1. So you have to make frequencies into probabilities, and then it's intuitive. Then you have possible outcomes here, say a minus, b plus, b minus, dot dot dot, and probability, right? Say so you will get probability for each outcome. And what you do first is use the probability as the weight for the corresponding outcome. So multiply them. Multiply the probability to the outcome. For each line, for each outcome, multiply the corresponding probability. And then sum, so I'm going to call this probability weighted outcome, right? Outcome is multiplied by the probability. And there are many, like say a minus, b plus, b minus, da 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 da, and then sum all the probability weighted outcomes. That's the mean, right? So mathematically, you can write them this way, but it's more intuitive to see, to understand from the table. So if you look at the table, you have, I recommend you to make another column to visualize what's going on, and write down the weighted outcome on the additional column, and then sum them, right? So let me show you with this example. So this is the frequency distribution table from the previous example of students, and say A once, A minus 4 times, B plus 3 times, B 2 times, right? They are frequencies, but let's convert them into probabilities. So it's easy. Out of 10 times, got A once, so 10%, and A minus 4 times, which is 40%, and B plus 3 times, 30%, 20%, 0%, right? So in this case, we are going to multiply the probability to the outcome. So there is no point of using percentage. So when you multiply the probability to another number, I recommended you to use fraction or decimal. So instead of percentage, so just leave them as they are, like this. So now it is a probability distribution table. And the next step is to multiply the outcome to its probability, right? So multiply for a 4 is multiplied, weighted by its probability, 0.1. Then the probability weighted outcome equals 0.4. And a minus is weighted by 0.4. So multiplication equals 1.48. In that way, you have to do it for every outcome, every possible outcome. Of course, if the probability is 0, the result is 0, so you don't need to do it. Anyhow, even if you do it, it's not wrong. It's 0. So and this you have to obtain probability weighted outcomes for every outcome with positive probability, right? So then you get weighted outcomes. Then the sum of the weighted outcomes is the mean. So 0 0.4 plus 1.48 plus 0.99 plus 0.6 plus 0 equals 3.47. That is the mean. That's the mean. This is how you calculate the mean. If you like, so also the point is the definition. The mean is the sum of probability weighted outcomes. And in this example, we have probabilities, or we could calculate probabilities from the data. If you use, like, you may apply the same, and we calculated the mean from the same data of two different forms, right? The raw data or frequency distribution table. But in many cases, I have seen many students in the past, so you may think this is too stupid. You may think this question is too stupid. You cannot believe how, like, I'm asking you this kind of question. You may be humiliated to be asked this question. But actually, I've seen if I put this on an exam, I've seen many students who say the average is $50, right? I'm not kidding. And so of course I will make the question a little bit more tricky, like writing down more about the the question more in the question, but still a lot of students are confused here. So for example, if I ask you what is the average of this, what is the average of this, then a lot of students don't know what how to do it, right? And they cannot distinguish these two. The main reason is because they cannot distinguish whether it is a probability distribution table or raw data. Raw data is easier to calculate the average, but when you have a probability distribution table, it's a little bit tricky, and you are not used to this kind of calculation. So uh, this is why I'm teaching you this, even if it's too basic. Okay, so I'll finish this and we'll continue in the next one with a new example. Yeah. See you later. See you in the next video.